Hello and welcome, everyone. Thank you so much for being here. My name is Teresa, and I am the general manager at Atrium. And we are super excited for you to join us for what should be a fun conversation and demo today. We're going to focus on something that a lot of builders run into. You've built a hook, you deployed it, and now you're sort of wondering, is it actually working? Is there, is liquidity being used the way I expect? Is there anything in the data that I should be paying attention to, or that's going to make me like the next trending story? And evaluating your project end to end can be, can feel surprisingly hard. So today's session is designed to, remove some of that, confusion or that layer of obfuscation and make it a little bit more concrete for you to actually understand what your hook is doing. I'm really pleased to be collaborating with Dune and Base today for a hands-on session walking through how to evaluate a Uniswap V4 project from start to finish using Dune as the analytics layer and V4 itself as the example. So whether you're in the weeds of hook development or really early on in the journey, just learning about Web3, hopefully there's something practical here for you from this conversation. As always, feel free to drop any questions into the chat, and we're happy to answer questions. As you have them, we'll have some time for Q&A after the presentation and the demo. I am also going to pop up in this corner here a QR code, and this is actually a form to reach out to the Dune team if you have any questions, if you're curious about using Dune after you have watched either this live stream or after you've watched the recording. The team is inviting you to fill out the form, reach out, and get connected with their team to be able to start using Dune. So without further ado, I'm delighted to welcome our guest, Jeremy Melvin, who is a senior data scientist at Coinbase. And Jeremy, I would love to hand it over to you to introduce yourself, share a little bit about your journey into Web3 and what led you to your work at Dune, and then dive right into actually using Dune.
Yeah, sure. Thanks for the introduction, Teresa. My name's Jeremy. I'm currently working at Base as a senior data scientist. I got into crypto and Web3 stuff with the 2017 cycle, and then tried to slowly work my way into some kind of career related to it. Before I was at Base, I worked for a startup called OpenBlock Labs, where we did data scientist consulting basically for protocols and ecosystems. We helped a lot with like incentive programs and stuff like that. So got a lot of exposure at that point to Web3 data, to blockchain data. Spent a lot of time on Dune, I've used other tools and other things like that as well. So I feel like I have a good take on a lot of the tools that are out there, and certainly Dune is one of the better ones. So
amazing. And then I'm happy to pop up your screen if you're ready to start talking a little bit more about how you use Dune.
Yeah, sure. Great. Okay. So I'll talk about kind of analyzing your protocol and crypto data. Just to kind of give a little bit of background, you could ask the question like, you have a node, there's data that's being, publicly sourced everywhere. And so there is still some challenges related to blockchain data, even though it's so open source and all of these kinds of things. And the biggest one is just you're dealing with massive data sets. And we'll talk about that a little bit more as we kind of move through a particular example. Another problem is that you don't have kind of like a fixed schema. Everybody who creates a protocol can create their own types of events. Fortunately, everybody who does DEXs seems to emit a swap event, but you can see here the difference between the parameters in a Uniswap V4 versus an aerodrome swap are different. The topics are different and so forth. So if you want to build anything custom, you have to basically handle all of these different cases one by one, and it becomes very overwhelming very quickly, especially if you're a small team or a small protocol and so forth. And so that's the benefit of tools like Dune and others that kind of do a lot of this kind of under the hood work for you to do this ETL stuff. In addition, when you're kind of working in development and you're building some sort of contract or something like that, you might rely on-chain data through RPC calls. And so you can make RPC calls to get current states. So you could get information on like current liquidity in your LPs. You could get like a current price and those kinds of things. But it's not easy to get kind of historic data from RPC calls. You can do it, but then you have to have basically like an archive node that you can query at different block heights and so forth. So it becomes very complicated to do it from that standpoint. So you really want a database, which is what Dune provides, right? Like the ETL index data into this database, and then you can reconstruct kind of time series from historic databases that store basically all of these events and logs and other things that are relevant. And so you're going to kind of reconstruct things from events. And again, we'll kind of go through this in a particular example here. So Dune gives you this kind of raw blockchain data that's now been indexed. And basically there's 4 key tables. Anytime you're dealing with an indexer like Dune, there's going to be 4 primary raw data tables: your blocks, transactions, logs, and traces. And then with a tool like Dune, you have a bunch of curated data or crowdsourced data. So one of the most popular ones is the DEX trades one, where they basically take all those different protocols that emit slightly different schemas for swaps and manage all of that for you and put it into a constant schema, aggregate it all together so that everything kind of lives in one table. Another common one is like ERC20 token metadata. So it's pulling that into a nice structured format that you can use. There's the Dune spellbook, which allows people to crowdsource basically DBT pipelines. So these are pipelines that will run and generate tables on some sort of scheduled process and so forth. So you have your raw tables if you need to go down to that kind of lowest level, and then you have a bunch of tools on top of it, curated data and other crowdsourced data that can really jumpstart kind of what you're going to do, so you don't have to build things from scratch from the raw data. So just to kind of touch on these 4 tables briefly, blocks are pretty straightforward, right? Those are going to allow you to monitor things like health and performance metrics if you're an ecosystem like Base or Solana or so forth. Transactions table, so every transaction that is written to the blockchain is going to live in the transaction table. And from the standpoint of like analyzing a protocol, right, transaction table is going to be useful to understand things like activity. How much, transactions do I have? How many swaps do I have? How many different users do I have? What is the behavior of those users, etc. There's logs. Logs are going to be anything where you look at an event. So if you're familiar with a block explorer, like Base's block explorer, you can go and there's a logs tab where it'll show you all of the events that were emitted as part of that transaction. And each one of those gets written into the logs table. So it's very useful for understanding the behavior of protocols. And this is going to be the primary source for protocol analytics or contract analytics. And then there's traces, and traces are going to give you like the full trace that it went through when it executed the transactions. And so this is very useful for things like contract creations and a lot of times for what we'll call hidden actions. So I'll open up an example here. This is on the Base Scan Explorer. This is a transaction here that, as far as you can tell by looking at it, had no real activity, right? There was no value transferred. There were no logs emitted, so no events were emitted and so forth. There was just kind of a change to state. But if we go look at the trace, which you can see over here, you can see there's actually a significant amount of things that happened in this transaction. And so each one of these kind of actions that happened are getting written into that traces table, and that can give you a lot of information about kind of the behavior that certain transactions go down. So you're going to kind of use all of these sources and then the curated tables like DEX trades and the Dune spellbook in order to try to put together something that's going to be useful for whatever kind of analytics you're trying to do. So I think it's most useful and for us to kind of walk through an example where we go through this. So I looked back through Uniswap V4 hooks, and C-Launch makes a lot of really cool dashboards on Dune. And one of the dashboards they have is tracking different hooks. And so if you look at hooks volume on Base per project, and we highlight over PolitiSwap, you can see that for a small period kind of in April and June, they kind of hit this top amounts, like maybe top 5, top 10 volume that was happening in hooks. And then it kind of died out. And so I think that this is a nice kind of like closed, contained example that had a decent amount of activity for kind of a short burst that'll allow us to kind of explore how we would kind of go about going from the beginning through to some sort of set of analytics in order to analyze it. So we can go to their website. Their website is a little bit defunct now. Hopefully it will load, but we'll just go straight to the docs because that's what's really important. Yeah, so here's their website. So it has a little intro on what they are, and then it has a link to their docs. And so obviously if you've deployed your own hook and you're trying to analyze that, ideally you have a pretty good feel for kind of how that hook works and the structure of things. But as a data scientist who may not be involved in the protocol, who's more trying to just understand the protocol, my first step is always to kind of go to the website, get a feel for what the protocol or contract is trying to do, and look at the docs, ideally for contract addresses. So if we look kind of briefly through this, we can see that they have a contract address for their token, but in their Uniswap V4 hook, they don't have any information on the contract address. And this is not uncommon. Docs do not always fully do this. So one thing I would suggest is that if you want people to better understand your protocol and you're building docs, definitely try to include the contract addresses as part of that. It's very helpful for other people trying to understand what's happening. So one other source that we can use for hooks, fortunately, is this hookrank.io, which basically takes every hook that's, from what I can tell, takes every hook on Uniswap V4 and curates a little bit of data about them. So we can see that this one, there's a whole bunch named Politiswap, but this one here is the one that actually has some significant trading volume and activity on it. So this is most likely the contract we're interested in. And so I'm going to click here and we can grab kind of the contract address. Okay, so if we go back to kind of the website and we look at what they are doing, we can see that they're tokenizing every elected official in the world potentially, and they're starting with all US Congress members. So they're going to generate a bunch of tokens. The tokens are going to be deployed onto Uniswap V4 and then tradable. So now the next question is, all right, if I want to analyze this protocol, what are the key things that I need to understand? And so for anything that's going to be related to like DEX and swapping, right, the key things that are usually are of interest are things like TVL, liquidity, volume, number of swaps that are happening. In this case, because they're generating assets, we're going to be interested in kind of a list of assets that they have. And we're going to be interested in things like their users and how are they active, what is kind of their retention and stuff like that. So we can go to the contract now that we have kind of that feel. And another thing that you can do, and again, if this is your contract, you probably have a good feel. But if you want to kind of verify that the contract is working well on chain, or you're kind of looking at another contract to try to analyze, you can go to the contract tab in the Explorer, and you get a lot of information in the read and write about the types of functions that were written into the contract. And so if we kind of work our way through this contract information, we can see that there's a Politiswap helper, which maps to another contract. So this could be a useful contract for us to understand as well. There's the pool manager, which looks like, if we click on this, we'll find out this is the original Uniswap V4 pool manager. So it doesn't have a new pool manager. It didn't build a custom pool manager as part of its hook. It's using the regular one. And the pool manager is going to manage things like liquidity and so forth. So that's going to be very useful to have this contract address when we're trying to understand liquidity in the tokens, in the token pools that are here. They have a get pool token count, which you can see there are 542 tokens that have been generated. And then if we look at the right contract to get an idea of some of the events that might be emitted, we can see that there's a function called deploy pool token. So that is most likely going to be a very useful function for us. And hopefully there is a corresponding event that will allow us to understand the different tokens that have been generated by this contract. So now that I have kind of a feel for the for the protocol, I'll probably pull up Dune at this point here, and I'll start kind of exploring. And so I'm going to go ahead and create a new query. Or actually, I guess even before I do that, for most protocols, what I'm going to do is I'm going to search Dune and see if there's anything related to PolitiSwap. And if we look at queries here, we're going to see that the only queries that are there are the ones that I created as I was kind of prepping for this. So there was no prior data that's there that I could kind of use as a guideline for how I might need to construct queries in order to understand what's happening in this contract. And then the other thing we can look for is if we go create a query here, there is on the left-hand side under blockchain data, there's raw blockchain data, which will be those 4 kind of key tables. And then there are decoded projects. So one of the benefits of Dune is that you can give them a contract address. And I think it's in one of these things here, contracts here. You can submit a contract for decoding, and they will decode it and build out a curated set of tables based on the events that get emitted there. And so if we look at decoded projects, and we look at something like Uniswap V4, you can see that for the kind of the key contracts that are part of Uniswap V4, they have a database for each one of those. And within there, they have tables for a lot of the events that are there. And these tables are very specific to the parameters of that event. And so you don't need to worry about trying to parse that from the raw data. So it's very useful to have a decoded project. So I would look there if there is any PolitiSwap in there, which there isn't. So I could submit the contracts for decoding, but at this point, for me to analyze it, I'm going to have to kind of build this from the raw data itself. So as we kind of talked about, some of the key things that we're going to be interested in are TVL, volume, transactions. So we'll call that, those are swaps here, users, and assets. And really, when you think about all of these things, TVL is liquidity in pools with these assets, right? Volume is the trading volume in these pools. Swaps are the swaps in these pools, et cetera. Everything kind of centers around understanding all of the assets that are associated with this protocol. So the first thing we really want to do is figure out if there's a way for us to programmatically get all of the assets that have been generated from this contract. And so we're really looking for a generator contract. And based on the fact that the contract we looked at here, this 0x4CD1, in the read contract had a tracking of the pool token counts, it's very likely that this is the generator contract itself. And so we could take a quick browse through the transactions to kind of verify that. And if we pull up all the transactions and we go to the end, we can see very much so that there are transactions that called the function deploy pool token. And so those are most likely where our tokens were deployed. And so if we click on those transactions here, we want to get kind of an idea of how that transaction is structured. So looking at this here, we can see that this generated it looks like it generated a new token, right? We created out of the null address 1 billion Gary Palmers. And then it looks like we minted a Uniswap V4 position. So most likely this function generates the token, creates the initial liquidity, creates the initial number of tokens for it, generates the Uniswap V4 pool, and creates that all in kind of one token, all in kind of one transaction. And so the key thing here is that we want to look for some log that is going to be useful for us to be able to track these transactions and get the relevant pieces of information, which in this case is going to be the token address for all the tokens that were created. And if we kind of breeze through the logs here, we can see here it's initializing a pool manager, it's editing the liquidity for the pool. And here, this one looks like the most useful one for our reference at this point to get the assets, which is pool token deployed. So this event here is what we want to build a query in Dune now to pull. We want to pull all of these events that occurred on this contract. So this address in the logs here represents the contract address that emitted this event. So we can take this contract address. We're going to go back to Dune here, and we're basically going to make a query on the logs here. So we're in our raw blockchain data. I'm going to pull up base, and I'm going to query the logs table. And if I look at the logs table, I can see that there is a contract address field. So that contract address is going to be the contract address that emits that event. So it's going to be this address right here. And in Dune, which is different than other platforms, they use var binary for all of these hexes. So you don't put these as a string in quotes, right? It's going to be directly there, and it's more performant, it seems. So that's a good advantage here. And then we're going to go back to the transaction, and we're going to look at what the relevant information is. So this first thing, this topic 0, anytime you're trying to process logs from, write a query for logs, this topic is going to be uniquely kind of associated with the event for that address. So this token is going to be the way that I can pull out this pull token deployed event. So if I come here, I want to also filter on topic 0. Oops. On topic 0 equal to that topic. And then if I come back here, I can see that topic 1, which is pull token here, is going to be most likely the contract address of the token that I care about. So to verify, I'll go ahead and click on that. And I can see that, in fact, yes, it is the Gary Palmer token. So I want to take topic 1 and represent that as my contract, as my token address here. And then I'm going to come back again, the pool ID. So for Uniswap V4, everything is basically in a monolithic contract. All of the assets are there. And the pool ID is going to give you the ability to pull out the particular liquidity and so forth from that particular liquidity pool associated with your token here. So the pool ID is going to be important information for us to track as well for each one of these tokens, since when the token is deployed, it also creates this Uniswap V4 pool. So that'll be our topic 2. So from topic 2, I can call that the Uni V4 pool ID. Okay. And then, so we're pulling from the contract address, pulling from the topic. Then the next thing is that anytime you're writing queries here with logs, as we talked about back here, these are huge data sets, right? The logs for base is 21 billion rows. So you don't want to do full table scans as much as you can avoid. And so the way to do that in Dune is you look for this partition column symbol. And you want to make sure that no matter what you do in your queries, you always, if possible, include the partition column inside your filter statement. So we're going to want to have some sort of filter on the block date. And when I'm first kind of doing this and exploring, I don't need to pull everything. I want to kind of test initially, is my logic kind of sound, and then expand it. And so to start, I'm going to just look at the date for this particular transaction, and I'm going to focus my query solely on that. So this is going to be cast 2025 0424. Okay, so I'm going to focus just on the block date equals April 24th. It's probably going to be useful for me to know what time, like what is the actual timestamp of this. So we'll pull out the block time as well. And then it might be useful for me to have the transaction hash for this creation event, or for this creation transaction. So I'll pull the transaction hash as well. But other than that, this should most likely give me all of the relevant information that I need. So I'll go ahead and run this query, and I'll see what kind of output I get. So looking at the output here, I can see that I have a whole bunch of transaction hashes. I have some token addresses, and I have some UniV4. So it seems like I parsed the contract correctly. We could go ahead and verify, does everything, or we parsed the event correctly. We could go ahead and try to verify this for this token address. So if I copy this, come into here and put it in the search bar, you can see that it's not found, and we'll talk about that in a second. I'm going to delete the 0x, and I can see, okay, it is in the token address here, and it looks like I captured it correctly. And it looks like I captured the Uni V4 pool ID, starts 9639. So everything looks like I'm capturing correctly, but this token address has a bunch of filler on the left because it fits it into like a 32 or 64, I forget exactly which one, bit hex number here. So we need to parse out specifically the contract address here, which starts at A97. So there's different ways to do this. I could do a substring on it, but I believe Dune has a nice function for this. So let me pull that up real quick. Okay. Okay, so I can also go to our binary functions, take a quick look at the documentation, and I believe it's going to be this strip. So there's a ltrim, right? Ltrim, this will return 0xa when it has the kind of leading fill. So this is exactly what I want. So I'll go ahead and take this var binary ltrim. We'll go ahead and put that back into my query here. All right, we'll go ahead and rerun, and we'll make sure that that parsed it out, and we can see that the token addresses look correct now. And then we can go ahead and verify again, take our contract address, and sure enough, there it is. Okay, so everything looks good for us parsing this. We can see that this actually returned 542 rows, and we know there are only 542 tokens. So it looks like all of the tokens were created kind of basically at the same time, which kind of makes sense if they were trying to create basically this app where they wanted to trade these. It makes sense that they manage the creation of these tokens. But if I were to generalize this, since I want to be able to capture any additional tokens that are created, I would then kind of generalize this to be a greater than equal to cast across this. And so, but now we have to be careful, right, from the efficiency standpoint, because now I'm scanning a whole, almost a year of data in this massive table. So there are various options that we could do to kind of handle this, but this is kind of once you have your set of queries kind of working, how would you kind of productionize it? And, something like Spellbook here, where maybe you do an incremental update that checks each day for new tokens created and appends it to the table, might be the way to go. But we'll save that for, a separate exercise for you guys, if that's something you're interested in. So for now, since we know that these are all of them, and just for the purpose of efficiency, we'll go ahead and just create this query with the equal sign here. Now, I can see a whole bunch of token addresses here, but that's not very helpful for me from a visual analytics standpoint. Like, I have to take each one of these token addresses, come back to my Explorer, type them in, and look up which token that actually represents. What I'd really like to be able to do is bring in maybe the symbol and the name of the token associated with that address. And so we'll go back to the Data Explorer here, and this is one of the curated data sets that Dune provides here. So instead of having to kind of rebuild this from ERC20 creation events, we can go directly into the prices and metadata table. We can see that there, if we go to base, there is a table called ERC20 tokens. And so we can left join into this, our ERC20s. So here's our tokens, our logs. And so we're going to left join on. So we'll take a look at the table here. We can see that the partition column here is on the blockchain. So we want to make sure that we include the blockchain here in our statement to filter the table as much as possible. And we're going to match here the token address to the contract address, which is going to be the token address in the ERC20 table. and it's going to yell at me if I don't tell it that this is on the tokens table, because there's a contract address in both the logs and the tokens table. So I need to make sure I define those. And same with the block time and the block date is probably fine. So now we've left joined this in, and what I want to pull is the symbol and the name. So after the creation, let's go ahead and pull in the symbol, and let's pull in the name. I'm going to just move this to the end here. Okay, and then we'll go ahead and rerun. And hopefully this won't take too long. There we go. And we can see that sure enough, we were able to pull in kind of the symbol and the name. So now we have a list of all tokens that have been created by this contract. So we have a good feel for, we have a way to operationalize getting all of the token addresses that have been generated by this contract. We know the pool IDs associated with the liquidity pools for them. We know which token we're dealing with here. And so that will allow us to now move on to our actual analytics that we were kind of interested in. So we have all the assets, and now we can start to try to pull in the volume, the number of swaps, the users, and the TVL, since we can focus on these specific token addresses. Okay, so to do that, we'll go ahead and move on to trying to look at the volume. So volume is going to be for a DEX like this. Every time there's a swap, we want to pull out the volume. So we need a way to get every swap associated with each one of these tokens. And so this is, again, another benefit of using kind of the curated tables and going to the DEX trades table. We do not have to try to rebuild this from swap events, from the logs that's already been curated for us in the DEX trades table. And so we can go ahead and left join again, this time into the DEX trades table. So we'll take a look at the DEX trades table, and the DEX trades, you can imagine, is also a massive table, especially because this is across all blockchains. So it's very important, again, for us to kind of focus on these partition columns as we build this. So we'll call this trades. And so the partition columns are going to be, again, blockchain. So we'll go ahead and take blockchain. We'll go ahead and take project here. Fortunately, in this case, we know that these are all Uniswap pools. If you were doing this more generally for something that was broadly traded on a blockchain, we might not be able to restrict a project. But in this case, we can. I'm going to restrict even the version here because I know these are all Uniswap V4. But in general, for a fully general one, these are probably things that we would leave out. And then block month is going to be, so this is trades, is going to be greater than, we know that this all started on April 2025. So there aren't going to be any trades before April 2025. And so it's good to focus the table on that, since that's a partition column, so that it doesn't bother scanning anything before that point. All right, so now that we've handled the partition filters, let's go ahead and do the join here. So we want to do any trade where the token bought address or the token sold address matches one of our token addresses. So we want trades.token bought address is equal to our token address here. So we'll take this here, and we'll do the same thing for the sell side, because we want swaps in both directions. Check token sold address is equal to that. Okay. And that should then provide us with all of that. And so then we need to pull in the relevant information. So right now we have one row per token. So we want one row per swap so that we can kind of get that volume. And you can see that there's an amount USD, which represents the volume here. So we'll go ahead and do amount USD as the volume in USD. And what other information might be useful? So probably the transaction hash as trade. transaction hash. So that's going to be different than the logs transaction hash. And this is the creation transaction. Okay, so it's going to be useful for us to get volume. In order for us to get volume, it's going to be useful for us to get all of the transaction hashes so that we can count like the unique number of transactions that had swaps in them. For users, we're going to use the transaction from field. So trades.transaction from as trader. And then we're going to, so we have volume, we have transactions, we have traders, and then the other one would be TVL. TVL is a bit more complicated. We're not going to be able to get that from the swaps themselves. So we'll leave that for a second query. But this ideally should give us enough information to begin to build analytics for these three kind of key things. And just to kind of verify where all this came from, again, my process would be to look at a token, one of their tokens, and look at one of the or buy or sell transactions, and look at the events. So here's the swap event. And if we look at the transaction itself, we can see that the from address is the address that receives the token. So in a lot of, this can be, especially as you get smart contract wallets and other kinds of obfuscated things through, arbitrage and other that, if you build token pools that have a lot of liquidity, this can get a little bit difficult. But in these kind of more simple cases here, fortunately, the from address is going to represent the trader that we care about. And so that's the reason that we can pull the from address here as the trader. And the amount USD, that's more something we're going to have to kind of understand from Dune DEX trade schema. But these are all well documented. And if we look at the DEX trade schema, we can see that the amount USD represents the value of the trade at time of execution. So this is really going to represent that volume quantity that we care a lot about. So we can build all this. We can go ahead and try to click run, and we'll see if this worked. I probably have mistakes since I'm doing this on the fly. So I'm going to go ahead and just pull up the canned query that I wrote for this. So we have aggregates here. So one of the things you can do in Dune is you can reference another query as like a subquery here. And so this is just my query that pulls in all of the token addresses. And so basically then I just join to the DEX trades table and look where the token bought address was my token address and the token sold was the token address. You can see that this is very similar to what we were constructing there. And here I took the next step of, once I got the data, of aggregating it into kind of the key things that we care about. So the number of trades, the number of traders, the volume, and so forth. And so I've aggregated this now in a way through using the group buys on the block date and the token pair, and aggregating the things that we care about. And when we do transactions from and transaction hash, it's important for us to use distinct because we want the raw unique counts, and sometimes you can get duplicates. Not in this case, but in more complicated cases there. And so if we look at the data set that this produces one row for each date token pair that has the trades, the number of traders, and the volume for that date. And so from that data, then we can look at kind of some charts to understand kind of the aggregates of this. And so looking at the volume, we can see that, in the first couple of days here, and if you spend a little time to research Uniswap by just kind of looking at Twitter and other things to see kind of what was going on, there was a lot of selling of Uniswap on Twitter, a lot of shilling of it. And so it makes sense that there was a lot of activity initially in those first couple of days. And then it seems that in terms of volume, there was it kind of dropped off. And then there was a period where it was relatively consistent for about a month, and then kind of slowly tailored off and until it kind of activity ended around the end of August. If we look at that from the trades perspective, we can see a pretty similar story, right? In that early time where the volume was high, we had a lot of trades happening. However, that month between kind of May and June, where there was a lot of kind of consistent volume in the maybe like 10 to $20,000 range, the trades were not there. It was just a handful of trades. So it looks like maybe there was one or two people that was trading, or maybe it was the creator who was kind of wash trading some stuff back and forth. It's not clear directly, but that would be something that kind of pops out to me just kind of looking at this as something that would be subject to further investigation, because that looks a little bit strange. And so to kind of drill in on that a little bit further, we could take kind of maybe some ratios. We could look at what is the volume per transaction on kind of a daily basis. And if we come back to my canned queries here, I did just that. So it's a very similar query here, except now basically I'm trying to get some averages and divide some of these by each other. And so we can look at the volume per trade, and we can see that kind of what we expected, right? The volume per trade was a little bit high initially. And then in that kind of period where there was constant, where there was close to constant volume, it was very spiky with very high kind of volume per trade. So one or two trades were kind of driving a lot of the activity. Another way that I looked at this was, well, what if we look at the highest volume trade, that's the top one, or the 3 highest volume trades on a given day? How much of the volume do they represent? And you can see at 3, after the first 3 or 4 days, basically 3 transactions a day were driving all of the volume. Even though in some of those cases we had, 10s, 20, 40 transactions, it really all came down to 2 or 3 transactions. So from the standpoint of a protocol, right, that would suggest to me that, right, we really only have 1 or 2 power users using this, and maybe we need to understand better kind of from a partition, from a segmentation of our traders, what are their activities? Why did some drop off? Was it PNL? Was it other kinds of things related to that? Can we talk to some of these traders? And so, in our Discord or something like that to get more information on what's going on. Or maybe this is something that we expect, right? But you want to kind of pull up these primary metrics, which can sometimes be a little bit misleading, right? If you just kind of look at the aggregate volume or the aggregate kind of TVL, it doesn't necessarily tell the whole story. You really kind of need to drill into kind of segmenting it into different pieces, especially, across groups of traders, especially looking at kind of the distribution. In a lot of protocols, we have a very, right skew distribution where 1 or 2 people or a small percentage, depending on the size of the protocol, are providing most of the liquidity or activity. And so it's really important to understand kind of the power user versus general ecosystem user dynamic that's happening on your protocol. We can also look at the traders, which are going to tell the same kind of story here. We spiked up in those first couple of days, and then we kind of trailed off activity until we just had 1 or 2 traders there that were still active. So that kind of gives you the idea of how you go from an on-chain kind of black box contract into something where we can actually look at some relevant metrics and understand trends that are happening in our data. I'll touch very briefly on the liquidity. So for TVL, one of the complications is that there's no, perhaps there's an RPC call you can make depending on the contracts. But from an event standpoint, the only way to get the current TVL is to look at all of the events where you add or remove liquidity since the creation of the pool. So you have to basically sum up all of the events since the creation of the pool. For Uniswap V4, you then have to do a bunch of Uniswap V4 math, because you have to figure out, based off of the liquidity, how does that translate back to actual token amounts, and how do those token amounts translate into US dollars, if that's what you're interested in. So there's a lot of moving pieces that are here. You're going to be using the decoded project here for Uniswap V4. So we're going to use the Uniswap V4 pool manager, and we're going to look at the swaps, because we need to know what is the current kind of tick that's active right there. So you're kind of mixing a bunch of complicated concepts together into one query in order to generate a TVL query. But I did put that together here. And you can see it is significantly long. And I will say, I'll touch a little bit on AI in a second, but AI has gotten very good at these kinds of things. If you're able to describe well kind of what you're doing and give it a little head start by providing kind of contract addresses that it may not be able to kind of discover on its own, it's very good at kind of putting together a query like this for you, where you either have maybe one or two small tweaks that you need to make, or that is going to work kind of as a one shot. But as we begin to outsource this stuff to AI, what's really important is that you understand how to validate the data that it provides. So in this case, I had it provide for each pool ID, the ETH amount and the token amount for the politician. And so one way that we can check this is we can go to Uniswap, which has a lot of this information aggregated. We can go to their pools. We can search for this pool here. It'll pull up the ETH Pelosi pool. And we can see that there's 1.93 ETH and 911.7 million Pelosi in this pool. And so that matches our 1.93 and 911 million. So that gives confidence that, since I had AI assist me in kind of building this query, that I've come up with a way to kind of validate it and make sure that what it's doing is correct, outside of just kind of going through and making sure the logic seems sound to me as well. So we can look at this in a daily fashion as well. And we can see that the TVL kind of tells a similar story in the first couple of days. And I'll make one comment here. In this case, I separated the ETH amount from the token amount. The tokens are not traded anywhere except for these ETH pools. And so even though if you look at, say, this pool here that claims there's $106,000 of liquidity in it, most of that is coming from the 911 million Pelosi, right? If you take 1.93 ETH, we're talking about maybe $5,000, maybe $4,000, $3,500. So most of this TVL is coming from Pelosi. And there's no way to realize this except through trading it back for ETH, right? There's no other conversion for Pelosi. So it's kind of misleading to use the TVL numbers like this, which are based typically off of some sort of like last trade price. So instead, in a lot of cases for these kind of long tail assets, what is more useful is to kind of look at the paired token and how much liquidity is actually in that. So I've summed up the ETH amount in all of these tokens, and that's what we're looking at here. And so you can see that the amount of ETH in these liquidity pools jumped up to about 20 in the first couple of days. So that's a significant, first couple of days. But then as we saw with all of the other activity, it eventually trailed off. And it looks like, after the trade stopped happening, there's actually still about 7.5 ETH left in all of these liquidity pools, which suggests maybe maybe these are owned by the project creator themselves, or maybe there's been an issue with actually getting money out of those contracts. So I think I kind of want to stop here to make sure we have time for Q&A, but I think that gives you a general kind of idea of how to go from events and that you're emitting kind of on the blockchain to something that you can actually visualize and understand. I want to touch very briefly on a few things. Just for AI, like Dune has an MCP. I would encourage you that if you are interested in getting into any kind of analytics or so forth, you get familiar with these tools and begin to utilize them. They are getting better and better every month. And, you really need to integrate those workflows for kind of how these things are most likely going to scale. There has been a massive difference in the most recent LLMs, Gemini 3.1 Pro, Claude Opus 4.6, etc., Codex 5.3. These are much better than kind of just one generation before it. So there is kind of a cost barrier there if you're a small team as well to get something that actually works. There's a lot of iteration you have to do with the smaller models and the earlier models if you are using those. So that's just something to keep aware of. Hopefully, prices come down and make this more democratized across the ecosystem as we go. I also want to touch on a bunch of resources that we have at Base for builders, and would encourage you that if you are thinking of building a Uniswap hook or some kind of protocol or something else, that you look at Base as an option for deployment. One of the things that we've rolled out recently is builder codes through the ERC 8021 standard. The idea here is that you register on our platform base.dev, you get a builder code, and you would attach that builder code as a protocol to all of your transactions. And that allows us to easily attribute the activity that your protocol generates to you as a builder. So, and this attribution we can use for things like leaderboards, analytics, incentives, resource allocation, and so forth. In addition, if you register your app through base.dev and deploy it on Base, you instantly get access to a set of analytics. The O1 team is registered on base.dev, and they tweeted this out not too long ago, a picture of their kind of analytics page. You can see that you get kind of number of transactions, transacting users, some growth accounting here, just first time versus returning users, just out of the box by appending a builder code and registering on base.dev. We can provide these kind of high level analytics. And then obviously you can use Dune and these other tools to build out more like curated views of your users and segmentation and so forth. We've also recently released leaderboards based off of all of this as well. And this is useful for kind of understanding where your activity ranks. You can tweet these things out and so forth. And we release these on a weekly cadence to try to make sure that we're capturing kind of new apps and so forth. In addition, we have a lot of programs that kind of help builders and devs. We just finished applications for batch 3. We've had batch 1, 2, and 3. And this one, we had 3 different tracks here, with different prizes depending on which one you kind of qualify for. These can come with significant prizes. Based off of the cadence that we're on, late summer, early fall would likely be where batch 4, if we decide to go ahead with that, would come out. So if you're kind of building on Base, and that would be a good place to target. But yeah, builder codes will help us kind of recognize your attribution, your activity on the platform as well. In addition, we have builder showcases kind of coming up at various different blockchain events around the world. So this is an opportunity for you to kind of come give a 1-2 minute pitch about your app and so forth. And so a lot of different opportunities for devs, for people building on Base, to help us kind of amplify your protocol and so forth. Thanks. I think we'll open it up to questions at this point.
Amazing. Yeah, I think really, really interesting and such a comprehensive look at like taking a hook and how to think about even what you want to start tracking, how to actually build that out. And you actually answered some of the questions that I had. I think there's no presentation conversation that doesn't include AI these days. So yeah, definitely it makes sense that AI is a great space for builders who are maybe not quite as comfortable building out queries to get some help if you can articulate it in plain language.
Yeah,
a couple of reminders for folks. So you can drop questions into the chat if you have them. And then also the QR code in the corner is a form for you to get in touch with the Dune team. If what you saw Jeremy build out is interesting and you want to start tracking data for your own projects, feel free to drop that or to scan that and then drop them a note, and happy to connect with you. Just a couple questions. So you laid out, I think, pretty clearly how to think about it. And it's important for devs to actually understand, what they've built, what the code is actually doing in order to effectively track, the analytics of their project. But I'm curious how you think about, what are the right metrics to track? Like what's signal, what's noise? Obviously you can track everything, but how should builders think about what actually matters?
Yeah. So this, it depends, right? The famous thing, but it really is kind of dependent on what the goal of your protocol is. But for something like this, right, where we're talking about Uniswap V4 hook or trading focused apps, right? A lot of times, kind of, especially for the bigger platforms, people focus on TVL, people focus on volume, maybe like monthly active users. And those are definitely useful metrics, but really drilling into them and understanding kind of from a segment standpoint. So, all right, yes, I have this much volume, but how much of this volume is coming from, recreational users? How much of this volume is coming from, bots? How much of this volume is coming from arbitrage activity? How much, and that can give you an idea of how much of it is kind of sticky, right?
Yes.
From a user standpoint, you have that kind of high level number, but then it's also like, all right, well, how many people am I retaining? How many people are new kind of on a weekly or monthly cadence? How many are churning? Can I understand, like, if those numbers begin to change, what may have caused that? Did I release something new? Was there some other kind of broader ecosystem effect that's kind of happening? Do I have new competition, et cetera? So again, it's really just kind of start with the high level metrics, but that can lead to misleading conclusions sometimes and doesn't tell you really the state of your protocol.
Yeah. And so I guess some of that is also just one, really knowing what you need to understand about how people are interacting with your, with what you built in order to be successful, in order to either make money or gain, TVL. I have one specific question from our lead instructor who couldn't make it today, but curious your thoughts. So he had asked, in particular, when you're working with return delta in Uniswap V4, is there a good normalized way of reporting that data?
Yeah, I mean, I think that it again kind of comes down to, what are you trying to extract? What's the key thing that you're trying to understand? But yeah, Uniswap V4 has its own set of quirks that you really kind of have to drill into and kind of test, I feel like.
Yeah.
And so I don't know the answer to that off the top of my head. I'd have to kind of look at it a little bit and then maybe, but yeah, a lot of times it's, all right, let me dig into this. Let me try a couple different ways to do this. And let me figure out what makes the most sense for what I'm doing.
So it sounds like no normalized way. It's about matching what you actually are trying to do with that swap.
Most likely, yeah.
Amazing. I'm going to pop up this question from Rudia. So any resources to learn about the join, like left join, inner join, more practice needed?
Yeah, so there's a lot of SQL resources out there. There are like leet code type SQL oriented platforms. I can't, off the top of my head, I can't remember, but if you kind of Google for like SQL leet code, there are a lot of ones that you can kind of begin to work through kind of those examples, look at how people solve them. AI is a great kind of tool for bouncing ideas off of for stuff like kind of generic SQL actions and stuff like that. I think that, most of all of the LLMs should be able to help you kind of build a program if you want to do that. And then there's lots of like boot camps and stuff like that as well. Coursera courses and stuff that can probably provide a lot of useful information there.
Yeah, I agree. I feel like there are definitely tons of resources for getting beginner work in SQL, but also, as mentioned, AI can be super helpful in helping you build out your queries. However, it's important to actually still have humans who know how to write SQL.
Yeah.
Very last thing before we close up. So, V4 adoption growing, and as more data is accumulating on chain, curious, where do you think the analytics space needs to evolve to keep up? Like, is there anything missing that you think needs to be built?
So there's a lot of good resources out there. I mean, I feel like the biggest pain point for me these days is kind of understanding contracts. You can spend a lot of time kind of trying to dig through transactions, dig through logs, try to look at docs, and still not come away with a good understanding of why certain transactions route the way they do, or why certain activity is happening.
Mhm.
I don't know what the solution is. Maybe it's maybe it's a set of agents that we can finally
Mhm.
build that can go out and figure this all out. But yeah, something around kind of helping out better understanding contracts and what you're seeing kind of
Yeah.
on chain and how it relates back.
And sadly, I think that's another case where AI might be the answer, but it's almost certainly also the problem, as there's more vibe coded contracts and apps out there.
Yeah,
Uh,
let's hope that the security problems don't multiply too fast here with AI.
Um, Amazing. Well, that does take us to time, and I really appreciate you taking the time today to walk through just thinking about analytics and using Dune. And again, for folks who are interested in talking to the Dune team, you can just scan the QR code at the top, and obviously Jeremy has given a bunch of different resources for how to actually stay in touch and build with the base team that I would encourage folks to take advantage of. But Jeremy, huge thank you for your time and your insights today. I really appreciate it. And honestly, just really, really interesting to see this, particular aspect of what builders need to focus on besides just actually building out smart contracts.
Yeah, great. And thanks for having me.
All right. And I am going to go ahead and end us there. Thank you so much, everyone.